All right, now comes the time where we are going to take all our algebra and our equation forms that we've talked about, and we're going to look at word problems, and we're going to take what we've learned about equation form and algebra and apply it to a word problem. So I'm going to do an example with you. We're going to talk about some different terms and how it relates to the problem. And then you're going to have some time to basically just work through some word problems and ask me questions, because I can't possibly show you every single word problem. I can give you some tips, but you've got to take and apply those in your own way. So our little scenario, a soccer ball is kicked from ground level. The path of the ball can be modeled by the equation h equals negative 0.2 d squared plus 6d, where h is the height of the ball and d is the horizontal distance of the ball from the point it was kicked, so how far it travels across the field. Write this equation in intercept form. So the first thing you're going to think about is intercept form. Intercept form means factored form. So I have to factor. So I'm going to get my equation and I'm going to think about how to factor it. So my equation is negative 0.2 d squared plus 6d. The first thing I notice is this number at the front. That number at the front means that I'm going to have to common factor. So I'm going to divide everything by negative 0.2. That leaves me with d squared minus, and I'm going to get my calculator out just to make sure I don't make a mistake in my head this morning. 96 divided by negative 0.2. And I'm going to get 30. Oh, I'm already making a mistake. If you've noticed, playing along, let's stop for a minute and see if we can figure out the mistake I've made. A couple, actually. I did not fully common factor that, if you're paying attention. If you're paying attention, they also have a common factor. Each one has a d. So I'm going to go back and fix that. So not only am I going to divide by negative 0.2, I'm going to divide everything by negative 0.2, and I can divide them both by d. So when I do that, I'm going to have d left there, negative 0.2 d squared divided by negative 0.2 d would leave just d. And then I'm going to do 6 divided by negative 0.2 d, which would be negative 30. So I have my factors. So I have written it in intercept form. So once it's factored, it's in intercept form. Second part, determine the zeros. Remember, zeros mean x intercepts. In a word problem, actually, we'll maybe wait and talk about that in a minute. So the zeros mean the x-intercepts, and the x-intercepts are the numbers from the factors with opposite signs. So if I look at my question here, my factors, actually I'm going to get a different color. This one's easy. The number from there is minus 30, so one of the x-intercepts is 30. The other one isn't so easy. When I look at that one, there's nothing added or subtracted because the number for the x-intercept comes from what's added or subtracted. So if there's nothing added or subtracted, therefore the x-intercept is 0. So we have x-intercepts at 30 and 0. So we wrote it in intercept form. That meant we had to factor. We determine the zeros. Those are the x-intercepts. So the x-intercepts come from the factors, but opposite signs. Let's see what's next here. How far apart, whoops, let's keep the equation. How far from the point where the ball is kicked until it hits the ground? Whenever it refers to something hitting the ground, it's generally referring to your x-intercept. Because if you think of what's going on here, we've got the ball on the ground, it's going to get kicked, it's going to fly through the air, and then it's going to land on the ground. And if you think of a graph, the ground would be your x-axis. So the point where the ball started and the point where the ball hit the ground again would be your x-intercepts. So anytime a question asks how far until it hits the ground, or how long until it hits the ground, you're talking about x-intercepts. So if my x-intercepts are 0 and 30, how far from the point where the ball is kicked until it hits the ground is 30 meters. So it is 30. I better check. I'm pretty sure it was meters in the question. Actually, it doesn't say. Oh, my bad. So it is 30 meters. That's a long ways. How far from the point where the ball is kicked until it hits the ground? It's 30. Yeah, we're going to go with that. So the point here is to understand that the x-intercepts represent the distance across. So the x-intercepts answer the question when it hits the ground, because that's how far the ball is traveling across. I think there's one more. Sketching the graph of this relationship. So I'm just going to write a couple of things down, like the equation. H equals negative 0.2 d, d minus 30, or the other form, 0.2 d squared plus 6d. So there's the two forms of our equation. We know our x-intercepts. Sketch a graph of this relationship. So if I'm sketching, it just has to be a rough sketch. It doesn't have to be perfect. So I'm going to make a couple of lines here. Whoops, oh, that's definitely not perfect. Figure that out a little bit. There we go. So we have got the height of the ball, and we have the distance it travels. And we know that the ball starts on the ground and at height 0. And we know that it is 30 meters until it hits the ground again. And we also know, because it is squared, that the shape of a graph is a parabola. So we know that the ball is going to go up in the air, and it's going to come back down, and at some point it'll reach its maximum height. So at this point, to make our graph kind of accurate, I want to figure out this maximum height. So if I have graphed enough of these graphs, we would know that the maximum didn't work very well. Let me make it better writing than that. The maximum should be halfway between the x-intercepts. So halfway between the x-intercepts would be 15. So we've gone across 15 meters. I want to know how high up it would have gone. So to figure that out, all I have to do is take out the d and put in 15, and I'll figure out my maximum. And you could use either equation to do that. Doesn't matter which one. I've decided to use the standard form that I was given at the beginning. So I'm going to do 15 squared times 0.2, and I'm going to add 6 times 15, and I'm going to get 135. So I know now that my maximum is 15. Oh, shoot. 15 and 135. So we've sketched a rough graph of that situation with a few points on to make it accurate. So when you know your x-intercepts, you can always figure out your vertex by finding the middle of the x-intercepts. So this always seems so easy when the teacher is explaining it. When you're reading a word problem, it's not always quite as straightforward. That's why you have to practice by doing word problems on your own. Last one, and then you're going to practice some yourself. At what distance from the point where the ball was kicked will it reach a maximum height? Explain. All right. That doesn't say anything about x-intercepts or y-intercepts or standard form or vertex form. So you've got to do some thinking. At what distance from the point the ball was kicked? So we've got our ball and it's being kicked. Will it reach a maximum height? So the ball is traveling through the air, boom, lands on the ground. There's its maximum. At what distance from where it was kicked will it reach its maximum? So really, it's asking for the x number of your vertex. So word problems are really just a matter of interpreting what the question is asking you and relating it to the math that we know, the vertex, the y-intercepts, the x-intercepts, the maximums, the minimums. So to answer this question, at what distance from the point was the ball kicked? Will it reach a maximum height? At 15 meters. So it will reach its maximum height when the ball has traveled 15 meters across the field. I'm going to change that to field. Explain, well, you could say something like, I know this because a quadratic creates a mirror image So quadratic is a shape that creates a mirror image or the same shape on either side of the vertex. So it creates the same shape on either side of the vertex. So this means that the vertex is in the middle of the graph, or in this case, the middle of the x-intercepts. It creates a shape that creates, I just repeated myself. I know this because a quadratic creates a shape that, oh, that makes no sense at all. I better fix that. Oh, goodness gracious. Okay, I know this because a quadratic creates a shape that is the same on either side of the vertex. The vertex is in the middle. So if I know x-intercepts, the middle is easy to find. All right. So you're going to try the word problems that I'm going to post as well. And you're going to get a few days to just kind of work through them and send me any questions you have if you're not sure about something. And we'll work through some word problems and make some connections.